In today's episode of Faraday's Law, we're going to be discussing these miracles of electromagnetic induction.
Faraday's law is mathematically expressed as this formula here, where we have E, which is the electromotive force, also known as an EMF. We have a negative sign, we have the number of loops in a coil, and then we have d phi dt, which is the change of flux over time. Now, flux, or phi, is also defined as the integral of B, which is the magnetic field, through the loop with an area, so this dA. And the dot product accounts for the angle between B and the surface normal. For us to understand these formulas a bit more, I have some scenarios for you of a bar magnet which is approaching a loop of a wire. So, therefore, as it approaches the loop, the magnetic field is going to increase, the magnetic field through the loop. And this is because the magnetic field strength gets stronger as the bar magnet approaches the loop. And this change of flux over time is going to induce the EMF. So this generates an EMF which also drives a current in the loop, which is going to look, something like this, like arrows going in a certain direction. Now, for us to understand this a bit more, I have different scenarios. The first one is where we increase the speed at which the bar magnet is approaching the loop. If we increase the speed, the change of flux over time also increases, and therefore, so does the EMF. Next, we have a loop with a greater area. If there's a greater area in the loop, more flux is captured, right? And therefore, this also leads to a stronger EMF. And here in this last little scenario, we have a tilted loop, which is going to change the angle between that dot product of B and dA. And this causes flux to decrease, also decreases the EMF. So as we can see, flux and EMF have a direct proportional relationship to each other.
Now let's apply this in the real world with contactless payments.
We see the circuitry behind a card. We have a coil which works as the antenna, which is connected to a microchip. Now, when we have a payment to make, the card reader/terminal creates an alternating current, which creates a changing magnetic field. Now, as we saw in our last formula, a changing magnetic field creates a change in flux. So when we tap our card, there is a change of flux in these coils, which then induces an EMF, which creates an electric current through these wires in the card, which then powers our chip, which requires energy to process data and communicate with the terminal for the payment to be processed.
These same principles also apply to wirelessly charging and so many other technologies used, for example, in electric vehicles. Therefore, Faraday's law is so essential in real-world technologies today. I hope you enjoyed my video and thank you.